Okay, so I'm going to talk about the plan, why I made this. So Linux tries to compete on price, and it's a lot different from Windows, but I have to give mine away for free. I can't offer a warranty. The most critical thing for an operating system is compatibility, and there's a lot of people that are amateurs that are they're trying to do GPU support. They might support 1 out of 5 machines or something. I've chosen greatest common factor, least common denominator, whatever you want to call it. Anyway, God said 640 by 480, and that allowed me to focus on adding value. Anyway, so the command line feeds into a C compiler. So if I say U0 count I64 I64, oh, I did I should have done N. Okay, let's do J. 4J equals 1J lesser equal to I, J plus plus. And if it hits a string by itself, that's a printf. That's retarded the C out. I can't believe they made something so retarded and ugly. That's grotesque. What kind of... Okay, anyway. What a retard. So, in TempleOS, you have real functions that return values. Oops. Anyway, count to 10. So we use exceptions. You don't have error no, so it's a big improvement over Unix. So if it feeds into a C compiler, what do you suppose you do to start a file? Guess what you do? Well, anyway, so directory. I started with C. Statements outside of function execute immediately. I added default arguments from C++, so we just say dir. Then I made parentheses optional. So it looks like Pascal. The side effect is when you take an address of a function, for a function pointer, you put address function. That's better than the original C syntax. So we're going to edit a file. You can come up off the bottom. Let's say, what do we want to do? U0 main hello world main. We can do a bunch of mains. Let's do that. So you say pound include test. I have to do a semicolon. So it did that several times. So today I'm going to talk about standard in, standard out. The vision is a Commodore 64, not a mainframe. We're not doing scientific computing. What did you do with the Commodore? You made simple basic programs. You made sprites. I can watch this. I can put text on. I can put graphics on the screen in one line of code. Pow! We got a. How about that? Nobody can do that. We have we can do sprites at the command line. Let's do the sprites are vector, but typically you convert them to bitmap. So I'm writing on the command line. Okay, so the command line is a document that's being edited. Okay, so we have a document editor, and the cursor location is where standard out gets put. Anyway, so the document format is the same all over the entire operating system. It's one editor, so you can cut and paste. All these are, there's one editor for the command line, one editor for everything. Now, what do you suppose? Let's put it up here. Let's go ahead and change the origin. So, sprite edit menu, set origin. I'm going to click up here, and we just shifted it down. Okay, so what do you do if you want to print a sprite? What do you think you do? You say sprite, and then Control R, pointer to sprite, number 1. So let's do that. Now we just printed a bunch of sprites to the command line. They're kind of hard to see. Anyway, that's not so pretty. So guess what? There's no way to do log operations like log files. I'm kind of. This is Adam. He's a executive task. We could look at all the tasks down here. Adam is in Adam and Eve. He's the father of all tasks. You can actually, let's get rid of this ugly window. Okay, so you can actually say, I don't know what I'm doing here. Adam, I never do this. I don't even know why I'm showing you. Adam log, hello, okay. So you can log to Adam. What I did is when FAT32 was threatened with patents, I invented my own file system, and I said, what can I do that's simple that won't get sued? So I did a contiguous bitmap allocation. So drive report. So I made a file system called Red Sea File System. It's like FAT, but I cleaned up the directory entries so they're fixed length 64-bit. So I have a RAM disk, drive B. What did you do with the Commodore 64? Everybody played with disk blocks. So I'm going to copy some files onto the B RAM disk. And that's my file manager. So now we have some files. Let's do a with the Commodore 64, you played with disk blocks. The FBI is not too happy about giving access to disk blocks because then it ruins their secret if they're recording blocks. I don't care about pedophiles. It's more important that ordinary people get information on, get cheap thrills like we had with the Commodore. Anyway, so we do a directory. We want disk clusters. So let's look at the cluster for the current directory, 715. So say dump cluster. Now we could actually write this cluster if we wanted to do read write. So this is the cluster. This is a directory block. You can see my 64-byte entries. It's designed to be, we want the kids to all learn how this works and hack it and have fun. Everything is accessible. Nothing is off limits. Anyway, so I was talking about something. So I'm jumping all over the place. So there's the standard out goes to the cursor on the command line window. So what that means is, well, you can figure out what that means. So if we make I64I for I equals 0, I less than 100, I plus plus %d carriage return. So you can see what this is going to do. If I hit F5, it crashes. Exceptions. We got exceptions. We don't have error no. We have it's 10 times better than Unix. We have real functions that we can even make this return a value, I64. And we can say return I. Now we just loaded that into memory. We can say who minus R, and main is a function this is like this list environment variables. If we say I64I of global variable, we say who minus R. Now we have a global variable. This is the environment variables. Now all tasks inherit symbols of their parents. So all task, Adam is parent of all tasks. So guess what? All of Adam's symbols are inherited by everybody. So you never need to include headers because Adam has all of that. Now if you want to do a recursive who, there's all the this is huge. It's not that huge. One of the critical things is I want you to see the light at the end of the tunnel. You hit F1. This is all the help. And under each of these categories, some of them are duplicates. Under each of these categories is an API. And I want you to see the light at the end of the tunnel. That's critical. That makes all the difference. I can master this. I can learn everything about it. That's a realistic goal. It's not very hard. You can probably do it in 100 hours, for example. There's a, if you hit F1, there's a demo index. These are all, I'm going to hit Control O. I just opened all the trees. Anyway, so these are all, it's got a ton of demos. There's a persistent graphics layer. We get a device context alias. That allows us to use a pen width and a color. Okay, so we clear the command line document. We set the color. We draw lines. We delete the device context, and then this goes directly to the persistent. All the arguments for all the default arguments are the most common. So the default for DC fill is there's a layer, a persistent layer. It's kind of for kids, but anyway. So if we do this, there we get that. The persistent layer is kind of cheesy, but the refreshed layer is done 30 times a second. So if you're writing to the let's just take it for example. So this has some sprites, some Walking Dead. Let's see what this. Okay, so I made a simple. I tried not to. I used arrays and not classes. I was trying to be conservative, to be as easy to understand as possible. So there's FIFO. There's array. What do you call them? Circular buffers. Anyway, so there's a draw it callback that the window manager calls 30 times a second to draw the image. In the other example, we were using the persistent layer, but that's kind of for kids. It takes a little getting used to, but you don't issue a request to paint. It happens 30 times a second. What you do is, well, this one is scanning. Normally we make an animate task that runs, and this one is doing it within the main game loop. Anyway, so nothing too exciting. The messages are different. There's only about 16 messages. Each one of them is you set a mask with a flag. So if you want key down but not key up, you set a flag, a mask, and then that filters what messages you keep and which you throw away. Anyway, where was I? You know what? There's not really a... so the standard out goes to the cursor location in the command line window. So there's a state. So we're not dealing with streams anymore. It's kind of like a hose that gets inserted. If I watch what happens if I let's watch this. I'm going to run this. Oh, it went to the bottom. Okay, I lied. Okay, so if I go down here and then I say pound include test, it defaults. Now if I cursor down, look at that. It inserted, you can't tell, can you? Let's go up here and do it. So I'm going to go up to this point, and I'm going to say pound include. I'm just demonstrating that it's probably not that surprising, but so it's inserting. Normally you don't do it this way. So this is all, I'm using cursor down, so we just inserted into the buffer. So what you can do is you can make this command window an infinite buffer by saying doc max, and then if you want to redirect it, you can save it. This is an editor, so I can go ahead and show you that it has this. I could just hit Control S. Save as. How about /home junk.txt. You know what's weird? Oh, anyway. So files that end in Z are automatically compressed and uncompressed when you load them. Anyway, so I'm going to do a directory. So here's junk. When I open this, it's going to look just like, oh, it's a different color. Well, anyway, the default color is black. So that's how you can redirect. So I was talking about logs. The file system has is contiguous files only. What I did is I have to differentiate myself. I make a simple operating system that's easy to hack. And one way I differentiate is I cherry pick what you can do with it. Instead of doing everything, I simply rule out certain things it will not do. You can't do log files. The reason is because my file system is contiguous only. That's one reason. Another reason is compression requires loading. We load and save whole files. So compression is for whole files. Doesn't work for partial files. So we use compression normally. That's how we normally operate. And then finally, we can put graphics in here. Control R, make sprite, Okay, let's just put some simple graphics. Okay, circles. So we're just going to put some graphics. Now, these, anyway, when you save, the graphics are stored as binary. I'm just duplicating a bunch of them. That's not going to show up very well. You can edit and move, shift points. So I duplicated a bunch of the circles. So when I click on them, I get duplicates. Anyway, so you can move them around. So they're vector, and actually what you normally do, it's kind of overrated. Normally you don't keep them as vector. I thought vector was really cool, but vector is only good for editing. Once you that's the kind of stuff that happens. So we can let's go ahead and delete that. So I just deleted that. Now let's go. Oh, you know what happened? This is an ordered list, and we just inserted at the beginning. We should insert at the end. We can't tell which circles have been drawn. I violated the order. In other words, the circle didn't exist yet in the list. Then you can convert it to a bitmap. I should have done, you know, when you do a demo, you should do something pretty. Anyway, so I'm converting to a big ugly bitmap. Then you can edit as a bitmap. That's no surprise to. I did flowchart stuff. I never used my flowchart stuff. Anyway, so now we have a big ugly bitmap. Now this goes into the file as binary. That's a binary bitmap. So so for example, if we dump that file, dump junk dot, this is going to unzip it. The raw image would be compressed. So here's the bitmap at the bottom of the file. It's binary. And then up at the very tip top should be the ASCII. We made a huge bitmap, didn't we? Just lovely. Okay. Dang. This is crazy. There's our ASCII. Is that, yeah, that's the big, I made a bunch of stuff. So there's ASCII, there's ASCII, there's a terminating 0, and then there's the binary. So one reason you can't log files is because what if there's a sprite at the bottom of your file and then you start logging, then suddenly the binary has to be shifted down. So we load and save whole files. That's just how we roll. So you might ask, well, I have tested it, and it meets my expectations. Here's a bunch of icons. So I made a, let's look at the, what's the other one? Oh, the first person shooter. So, so you can do 3D meshes inside of your sprites. Can include 3D meshes. It's the editor for meshes is very tedious. I don't do very much. So there's 3D mesh sprites in here. They're done with triangles and vertices. I do a random dither in order to get more colors. It looks kind of strange. Everything kind of... Anyway, so this is a first-person shooter. Anyway, So I think I showed you around. We can go to the Oracle, get Mr. God to talk. Oh, you can just hit F7 at the command line. Astronomical who are used to judge cosmos. Hey, that's right, Chase. I didn't see that wastoid. Okay, let's go to the Oracle. This is kind of stupid. I guess it's stupid. So this is Moses. You go up the mountain. Then you find the burning bush. Where's the burning bush? There's the burning bush. Now we talk to God. Sit on his throne as it is this day. And now, O Lord my God, thou hast made thy servant king instead of David my father, and I am but a little child, and I know not how to go out or come in. And thy servant is in the midst of thy people, which thou hast chosen, a great people that cannot be numbered nor counted for multitude. Okay, that's lovely. Well, anyway, I'm king, okay. So, the best part is hymns. You should do offerings, and then you get God's response. This is a nice little song. Father, the grass is green. This must be a dream. Thanks, my shepherd, you are good. Thanks, my shepherd, you are good. God is a good God, thank God. God is a good God, thank God. He is a good God. He is a good God. God is a good God, thank God. God is a good God, thank God. He is a good God. He is a good God. Do not push your luck. Do not push your luck. God is not a schmuck. God is not a schmuck. No. Do not tell the Lord that you're feeling bored. He will send the sword. He will send the sword. Yep. Okay. So, do hymns and then God responds. Hope that's right. Okay. So, what do we, I'm a rocket scientist. So I did feedback control systems I studied. So this is, there's a differential equation engine. This one's misses. This one's uptight. So, you can play with the differential equations. Rocket science. If you want to do it open loop, this is impossible. Open loop means you don't have your control system. It'll crash. It's impossible. Okay, so open loop, closed loop. So I hired an artist. He did some good work on a couple things, but he put penises everywhere. Everything looks a little bit homo. This is kind of amusing. You know, they got dicks on the Sistine Chapel, so I'm doing okay. I got one of them real homo artists. Put dicks everywhere. Sistine Chapel's full of dicks. I don't know. He could have stolen this from some other place, but anyway. Oh well. I like what he did, sort of. Oh, this is nice. This is nice. So, we have some 3D meshes. So, good King Wenceslas, you go in a blizzard and you let people walk in your footsteps to get to the warmth. So they set Yule logs. Let's get this guy inside the house. Hey, come over here. So making a game, the first thing you want to be is original, and then you want to make it fun. So I made several original games. where's Rawhide? So this, okay, so Control Z, or Control Shift, Control Alt Z zooms. Control Alt Shift Z. The API has controls. The API has Control Alt Z for zooming anywhere, anytime. So if you're editing bits, you can zoom in, and you can pan with Control Left Drag. So every window that's part of the API can be panned. So that makes it easy to do certain games. So this game, I didn't have to make my own panning. The game pans itself. So we got to get those cows into the fenced area. Okay, this is. Screw this. Anyway, so you can get the cows in. I think that's it. That's all I want to show you. This is the wallpaper. There's 8 cores. Let me show you an 8-core flight simulator. So this is doing, if you look up in the corner, it's showing the cores. Anyway, so that's 8 cores. We're not using a GPU, so it's possible to use multi-core. GPU is better, sort of, except for it's not transparent. So we want to be entertaining like a Commodore 64, which you could hack, and so we want it all in the open. So we have a you can browse code with the autocomplete. So GR triangle, GR fill triangle. So you want to know what separates a professional from, well, I did my own triangle fill. It just takes algebra, but most people can't do algebra. Most of the other operating system developers, they cannot do their own triangle fill. They're stupid. No, it just takes, it takes a genius to do simple algebra, because everybody forgets and doesn't have the stamina. I don't know. It's crazy. So it's a usable operating system, and it's got features. It's not pathetic. You know, most people, I've seen other operating systems. Why would you use them? Well, this is awesome. You should see the hymns. If we go look at the code, let's go look at Prosper. So you should do hymns. Everybody should do hymns. So we have some sprites. We have a draw it. That's the one that gets called 30 times a second. It draws a couple sprites. This is the lamb dances, and the music is coded with it's a simple one voice, so it's really easy. It's just notes, and then the words are there's 2 strings in the play, the notes and then the words. They go with the notes, and that's how you do these songs. So these songs are really beautiful. They're made by angels. Let's go look at the best song by the best angel in all eternity is. Let's go look at what makes you think you're God? What makes you think you're God? Do you think I'll applaud? What makes you think you're God? because I am. Are you a fan? What makes you think you're God? Okay, that's God. Okay, well, that ought to do it.